Good evening, everybody in Bulgaria. Probably it's not so evident from my name, but I'm Bulgarian. I was born in Varna, and the first 39 years in my life I spent in Bulgaria. I got my engineering degree at the Technical University in Varna and my PhD degree at the Technical University in Sofia. But then in 1992, end of 1992, I moved as a PhD, as a postdoctor at the University of Delaware, where my long dance with AI has begun. And here I'll begin shortly with showing my condensed view of my industrial experience, mostly in the US economy, starting as a postdoc with Texaco, where I implemented expert systems and neural networks in the early 90s. Then the biggest jump in my career happened between 96 and 2014 when I joined Dow Chemical, the largest chemical company in the United States, first in R&D, then in their new formed business function of AI analytics. Then I retired and created a consulting company. My first client was another large corporation with a different type of business. In fact, office equipment called Steelcase. For example, Apple and Bank of America, the office equipment is based on Steelcase products. But my key accomplishment, late accomplishment, began in 2015 when another industrial giant, Georgia Pacific, one of the largest manufacturer of paper, pulp and paper in the United States, asked me how to introduce AI in their company. And since then, more than 9 years, I'm consulting them. And last year, I was asked by one of the leading AI development companies, Parabol.ai, one of the leading company that used language models even before the explosion of ChatGPT in 22. They began in 98, in 2000, and I'm sorry, 2008, 2018, at the beginning of the language models, using them in industry. And we had a project at that time. So meanwhile, I had published 5 books, one of them translated into Chinese, 70 papers, etc. And last year, I published my Bulgarian book about introducing AI. And above all, with the idea that at that point, AI is not only a technology, it is a way of life. But the topic of our meeting here is to focus on my experience, how to use AI in industry, how to apply AI. As you saw, the list is long and heavy. But what happened in December 22 with introducing of ChatGPT is on the one hand, AI had become accessible and popular. Probably 300 million people can play with AI, with a large language-based AI. But it is not the basic AI. It is not the hardcore AI. That's why we saw this process of big dilution of the technology. So we have here the people building AI. Then we have hundreds of millions of people who are using AI. And we have maybe 1 billion people who are talking about AI. AI can become a media event, which unfortunately created, to me, a little bit biased image of the technology. What I'll talk about here, and I divided my talk in 4 parts. First, let's make it clear what we are talking about, what we mean by AI, and its successor, current successor, Gen AI, generative AI. Then I'll answer the question when and how AI had transformed from a research category to a business approach. Because now what's the most important fact is that AI, especially in the United States, is the engine of the digital economy. How that happened and why it's important to know this transformation. And I'll show this transformation, the value creation potential of this transformation by several specific projects. And all of them are my projects from these companies I have shown. And at the end, I'll try to address the most important issue for you, how to apply it, how the business can introduce AI in their practices. Now is the time to do that. But let's begin with clarifying what we mean by artificial intelligence. There are gazillion definitions. Even there is a book, more than 100 pages with definitions. Even a couple of months ago, the European Union has suggested another definition, which I don't like by one very simple reason. The word intelligence is absent in this definition. What I like in the definition I suggest here is that it is based on this word. That here the definition of AI is that this is a branch of a computer science that studies the properties of intelligence by synthesizing intelligence. As you can see here, the word intelligence is twice in this definition. And then the next step is that what we mean by properties of intelligence, that properties of of the intelligence we know. And here the assumption is this artificial, this machine intelligence is good to have these 4 modules. Communication one, that can allow the machine to understand us, to recognize speech, text, vision, to have a memory, and above all, to have 2 key features, to learn and reason. This is the way that the research community had defined it in the most compact, way. What is important as a next step after this definition is to define the capabilities. What do we mean? How an AI system can be differentiated from another technical systems. And here are the 4 key capabilities that are typical for an AI system, which must learn, predict, reason, and at the end, help us to solve complex problems. This, when we are talking about AI, and when a company claims that we're building AI products, they must pass through this filter and answer the question, does their system have learning capabilities? Does it predict, or even better, do business forecasting? And above all, does it reason? What's the reasoning mechanism? And I can tell you that maybe 90% of the claims can disappear and cannot pass this obvious test about the capabilities of an AI system. How we can build these capabilities? And there's another fact we need to understand, that AI is not one monolithic method or technology. It's based on various methods that can allow us to build different systems that can have these unique capabilities that we talked about in the previous slide. And here is the short list of the key methods. And two of them are at the basis of almost most of the applications. Neural networks that, in fact, began and they were designed with the idea of mimicking how our brain operates. And with this small type of neural networks of, let's say, based on hundreds and thousands of neurons linked in a network, the machine can automatically identify patterns. It can predict, it can classify. However, the explosion of the data 20 years ago have shown that in order to do more complex tasks, to process images, sounds, to understand natural language, we need something more. We need more complex structures. And here the most important method had been developed about 15, 17 years ago, called deep neural networks or deep learning networks. And that is the basis of the breakthrough. In fact, the systems of the deep learning networks had grown tremendously, and the breakthrough that had been done 2.5 years ago with large language models, with so-called generative AI, it is based on very complex deep neural networks. So complex that the number of parameters are measured in trillions. But there are other technologies. I'll not spend time on them now in this presentation, but it's good to know that the capabilities of AI, they do not stop with neural networks. And I'll especially pay attention on two technologies. One is evolutionary computation, which allows us simulating evolution of different structures, entities, in fact, to generate novelty. One of the weaknesses of neural networks is that they are not a novelty generator, but there is nothing more powerful in generating novelty than evolution. And all the biological evolution is a simple proof of that. And now we have capabilities simulating this in a computer to do a lot of new things. And now a potential marriage between evolutionary computation and large language models can give us a new universe of novelty generation, Gen AI. And another technology, which I'll mention in a couple of slides, which is growing now exponentially, is the intelligent agents. The world of Gen AI is definitely going, especially this year, in the direction of intelligent agents. So these are the building blocks. And I call it basic AI. But in the year of 2020, and first in the year of 2017, a new approach calls transformers with attention allowed to build a special type of deep neural nets that's very capable of generating text and processing text. And that allowed to feed a very complex neural networks, deep neural networks, with a lot of text, with, in fact, almost anything that's possible, approachable, and open in the internet. And then, after we feed this text to this monster with trillion parameters, we tune it by some genetic algorithms, optimization algorithms. And in fact, we have, within this 1 trillion parameters, we have the world knowledge, the average world knowledge on any discipline, on any facts. And it sounds great. And the mechanism is, then we can ask some questions. The name here is prompt of the question. This question in text can be transferred into numbers called tokenization. And then we can go back to as numbers and try to fit this text with this transformer algorithm and to find the best answer within this 1 trillion parameters. The algorithm is such that it finds the answer word by word in a sequence of words. And that's how these large language models, one type of them, autoregressive large language models, can deliver answer by predicting a sequence of words. It turns out that in many situations, it sounds very good. It sounds very reasonable. It can help us to do a lot of tasks with this way. However, it's not trained, it's not tuned to the specific knowledge. In fact, it's as if you have a very talented high school guy in his 12th grade who knows everything, who knows geography, chemistry, physics, etc. But you don't have a deep expert in chemistry or in physics or in some technical discipline. For that, you need additional tools, additional metrics. But now it's not the time to discuss all the nitty-gritty details of these methods. Only I would like to show you that the last step into the AI is the so-called generative AI, Gen AI, which became popular. And by the way, if you ask anybody what this person means about AI, there is a 90% probability that the meaning, the understanding of AI is related to ChatGPT, to Gen AI. Here, however, the field of AI, the community of AI, faced a big division. The big division is not only in politics, it's in science too. And at the basis of this division is the different strategy how to develop, to design an AI system. The one camp, which is the leading camp now, is the so-called non-structural artificial intelligence. It's based on the so-called scaling law, and it's specifically valid for large language models. And this law says The more parameters we have in a one big neural net, deep neural net, the more accurate models we have, the more accurate prediction we have. And here is on the right part is, for example, the difference between 7 billion parameters and 65 billion parameters. The red line is that means that the most complex model has the minimum error, has the minimum loss function. And the idea here, and as a big proponent, is Sam Altman, the leader of OpenAI, will build the bigger models. Now he has this crazy idea to go to the Arabs to ask them for $7 trillion and to be super monstrous next large language model. What is characteristic for this approach is that it is cheap. It doesn't require, in fact, R&D. It's a brute force. In fact, this is a black hole. We don't know what's inside it. I came from a researcher. I'm terrified by this approach, by the way. Just the opposite is the approach led by Jan LeCun, who is leading all the AI research efforts at Meta. And he's one of the inventors of deep neural networks and of the convolutional type of neural networks, which are the basic type of neural networks for image processing. And his idea is, look, first, intelligence is not only represented by language. We have animal intelligence. Animals don't understand language. Babies don't understand language until some period of their time, all the meaning. So, number one. Number two, our brain is structured. That means that the human intelligence is structured. And let's begin with the structured approach, where we understand each step in designing an artificial intelligence machine, then throwing gazillion parameters and dollars on something we don't understand, which, by the way, can be dangerous. So, and here I'll stop with the first part, explaining what AI is, the key methods, components, and above all, this ideological divide, which I would like you to understand. What are the next steps in the near future? And at least for this year, it is very, very clear. And the first step, they already had began. Now, the progress will be from language models to multimodal. Very soon, we'll have all the media dimension, needed media type of dimensionality, image, video, sound in these generative models. It will be given. It will be forgiven. The next approach is to decentralize the knowledge by so-called Gen AI agents. I'll not spend time on this, simply to know that there is another revolution in the horizon, especially with the Gen AI agents, and probably this will be a subject of research and development in the next 5 to 10 years. Now, let's go to the business. First, when this transformation happened, how, and here, by the way, before ChatGPT, the impression, especially in Bulgaria, was that AI is a very abstract research activity. And I spent a lot of time in the last 10 to 15 years to tell guys, this is not research. This is business. It's in every large company. Wake up. And how did this happen? Because I was in the kitchen all the time. The first thing that happened is, and it was in the early 2000s, when the technical giants understood that AI can fit to their business model. When they realized, especially Google, when they realized this, and they changed the business direction, the business strategy, in a couple of years, there was a big brain drain from the universities to the companies. This was the one important fact. And here I give some numbers about this, from some top university to some of the giants. But during this process, what's important is these guys who were pure researchers, fundamental researchers at the universities, had transformed to business R&D activities. That means they do research, but this research is business focused. The objective of this research is creating products and profit, not publishing papers. There's a big difference. And what happened also is that the giants created a lot of new algorithms, new infrastructure, and they shared it with the businesses. They were smart enough not to close it, but to open it to the business community, because they knew that when you open it, you enrich it with more ideas, you'll find the bugs earlier, etc. And in a period of about 10 years, in fact, all the big businesses began to create their AI groups to implement the algorithms created by the giants. And I can tell my personal story. When I joined Dow in '96, we were R&D. We explored AI algorithms. We, for example, explored, even had PhD students for support vector machines, for genetic programming, etc. But after 2007, 2010, we asked the question, why we need to do this? We cannot compete with Google or Microsoft when they have thousands of researchers and a much higher computing capacity. Let's use their algorithms and try our job to be to solve business problems with their fundamental research. That means that accelerated the business transformation significantly. Not to mention that it reduced the cost toward practical, instead of exploring algorithm, instead of the cost of R&D to be purely abstract at the abstract level, it went to a direct to manufacturing, direct to the business solution level. And here in the right part, I give this table which shows that in 2019, almost 2 million employees in the US industry, 2 million from 160 million, had been involved with AI. And about 184,000 of them are developers, are data scientists, are specialists that develop AI systems. That's why I may claim, and I may claim with facts, AI is a business category. It's a business category in the US since maybe 15 years. Stop the illusions about universities in this case. And here is another important slide which shows the dynamic of private investments in AI in the last 10 years. You can see in 2021, it's jumped to $93 billion. And to remind you that 2021 was the year of the COVID. And some skeptics thought that, oh, COVID will kill AI. Just the opposite happened. Because some of the features of AI had helped in the difficult transformation that most of the businesses had to do in the second and third quarter of 2020 when the COVID wave began. And only with some of the methods of AI, you can do it. And I was at the center of the storm at the time because the company I consulted, as I mentioned, it was a paper manufacturer. And you may laugh, you may not, but the demand for toilet paper had jumped 74% in April 2020 in the United States. And how you could reorganize huge manufacturing, increasing your production with 70% in weeks, only by consolidating a lot of technologies, knowledge, etc. And talking about knowledge, another change that COVID did in AI, before that was this paranoia. Data first, data, big data, 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 data. Yeah, but when COVID happened, we didn't have data. The previous case was 100 years ago with the Spanish COVID at the time. The economy was different, everything was different. And the only thing that can help us was the expert knowledge, the real inventive minds that we had in the companies. And that's why we decided we went too far with the data. We need a balance. And now it's, we went to the other extreme. Now the slogan is knowledge first. I think the combination between knowledge and data is the solution. But to switch your attention even to the lower graph, because for you, it's very important. It shows the geographic distribution of this investment, of the private investment, across the three key areas. United States, 53%, China, 17%, and Europe, 6.4%. It's not a good number for Europe. I don't need to comment more. But at the end, we have this business landscape. After this transformation, we have a big division in the businesses. We have the Olympians, or the Magnificent Seven, or you can use any name, which the technical giants, which concentrate and monopolize the AI research and infrastructure development. Then we had the big businesses. In the United States, the majority of the Forbes 500 have AI groups. They have done the major transformation and introduction of AI in their business. This is a done deal. This is history. What is not history is the transformation of the business solution with AI to the small and medium-sized businesses. It's not an easy process. And we began doing this process, but at that time, there was another event when ChatGPT came, and then the masses, it gave the chances to the masses to generate business solutions for some type of the small businesses with Gen AI. And in this case, now the small and middle businesses, now it has two opportunities. From below, from the pressure from below, from Gen AI, everybody to have some ideas and to create a business solution. On the other hand, to use the experience from the big businesses to downscale some of the solutions to the small businesses. So now is, with two words, now is the best time to begin to introduce AI in a small business. So, but this expansion will not stop in the business world. It continues now in the social world. I'll not spend time here because here the issues are a lot, and the purpose of this lecture is not society, it's the business. And let me show you with specific facts what's the impact of this transformation of the business. And here with one project, to show you how AI can reduce cost. And this is my ultimate project among the 200 I have done in these several companies. Dow Chemical, this is with Dow Chemical, is, as I mentioned, the largest chemical company in the US. As a chemical company, it has tremendous cost for raw materials, on average $5 billion a year. Now, the question is, when we negotiate it for the next year, the cost of the most expensive, for example, this is, for example, for a material which cost is about $250 million. It's one situation to make a decision in the upper part when you don't have the help of AI. You have to understand you have to make a decision based on the report, on opinion of experts, etc. But it's a quite different thing if you have a reliable, nonlinear, multivariate. Remember these two words because they, in fact, represents the power of AI. Forecast about the next 1 year. And now you can build your purchasing strategy knowing, for example, that in the first half of the year, the price will go down, then it will go up, and then at the end of the year, maybe it will be static at some point. But by doing this, and we built for the top 51 most costly raw materials, we build models. Not all of them were as perfect as this one, but on average, we saved $125 million. This is a project that is used for more than 10 years. Do the math. Next example, and this is from my current, from the paper manufacturing company, from Georgia Pacific. And here the bottleneck, the nightmare, is the frequent breaks of the paper machines. These are huge machines. And what we did is we built a doctor, a health monitor, that based on 50, 60 process parameters, it can detect some patterns of potential breaks in advance to allow the process operators to take actions and to avoid the break, to avoid the shutdown of the paper machine. And you can see here in the left side, what's the breaks before introducing the system and then after introducing the system. Only for this test period of about 3 months at the end of 2018, when we applied this project, the economic effect was about $3 million. And the potential is for 60 paper mills in the company to build this, to introduce this health monitor. But the most important impact is, especially for a company like Dow Chemical, is in accelerating a new product, introducing the introduction of a new product in the market. If you succeed to introduce it, sometimes it's measured by $1 billion. And the bottleneck here is building a reliable model, process model. You may have the chemistry of something. You may have some chemical process to produce it, but what are the relationships? What are the physical chemical mechanisms to have this understanding? Sometimes you're losing months. And here, with using this genetic programming approach that can generate automatically complex mathematical expressions, formulas. In fact, we did a parallel exercise, and what took 3 months to the best programmer to build the fundamental model, it took him about 10 hours by starting with potential set of mechanisms by representing by these mathematical expressions. And recently, where I'm working, which I think is a new direction, where the business, especially in manufacturing, is going, is to build the so-called digital brain of the enterprise, to consolidate this collective knowledge by which a company is run, which is subjective, which is changing, which is sometimes distorted by politics, etc. The idea is, can we distill the knowledge from different sources? First, by language models, but in this case, we collect the domain knowledge, not the generic knowledge from the internet. Then this knowledge is validated by data and tested, the reasoning mechanism, by this new technology called knowledge graphs. And above all, the new revolution in pattern recognition in relationships is transfer from statistics, from correlation-based statistics toward causal models. When we make business decisions, in order to be sure, to be correct, we must clearly know what is the root cause of our actions. And we have been, in fact, punished by purely correlation-driven decision, which could be fake many times. And now it's an expensive process. But now what we did is, with our last two projects in the companies, we built this digital brain that allows us to do a proper business optimization. When you optimize, it's not only finding the maximum, for example. It is the way, the degrees of freedom you give to the machine to find the optimum, all the compromises you need to do. And here you need intelligence to do it. And this is my last project, and this is a gigantic project. At the end, this slide shows that the companies that apply AI are between 3 and 15% more profitable than the others. And look at the difference between the orange curve and the blue and the green curves. So this section tells you, to summarize, that there are a lot of value creation opportunities. I have shown some of them. At the end, if you take the risk to apply AI, there is a very high chance to be more profitable than your competitors. So now, and probably for you, you begin your journey, if you desire, of course, not with the basic AI, where all these examples are given, but on ChatGPT, on Gen AI. What are the opportunities that it gives? Here is a slide that shows the paranoia. I'll skip it. You know the paranoia. You probably, you're listening it all the time. But here are some of the key opportunities that Gen AI gives. And especially, it is good in personal development. Each one of you can enhance your productivity with ChatGPT. Even to the credit of Insight, the fact that they had opened and created a Bulgarian language model, I think it's a very good, it allows everybody to begin this journey. And here are some 3 areas where ChatGPT and Gen AI had been applied many times. and especially with customer support, with feedback analysis of comments, feedback, with handling returns and refunds. And it's a study published in Harvard Business Review, even I think it was last week, an analysis how people are using Gen AI. 100 categories, and here I give the top 10 of them in several uh, themes. Technical assistance, 23%, or content creation, or personal support, learning and education, creativity and recreation, research analysis, etc. Talking about creativity, one little detail. A lot of the criticism on Gen AI, on large language models, is with their ability to hallucinate. And it's really, for some serious business, it's a very bad property. And there are a lot of efforts to minimize it. However, for some activities, it could be a good thing. And now I'm even in a small project with one of the largest schools in Atlanta, where the key idea is how to use uh, how to use hallucination to increase creativity and learning the students. So think about this. This is up to your imagination, to use it. However, some warning messages. First, you need to take into account that the content validation will be needed, especially in business applications. You're not sure due to this hallucination component. You have to spend more time to validate, or to organize the data flow, the initial data flow, with technologies. And now there are a lot of new technologies which filters out the data, your business data, to the large language models, to filter out, to minimize the potential of hallucination. But this is an additional cost. You need to know programming, you need to know prompt engineering very, very well. But the most difficult challenge is in the way you evaluate models. With the basic AI, usually we have quantitative metrics. We have a model that predicts. Here, I'm showing you this model in the left side. It predicts, by the way, the quality of a toilet paper. And it was one of the first things we did in the first days of April 2020 to help the company to evaluate this quality online, not based on lab measurements, which slows down the process, the evaluation process. But what matters here is that the products of the basic AI, usually their quality is numeric, and we have a clear metrics to differentiate a good model from a bad model and to change the models all the time. Unfortunately, when we deal with text, it's not so obvious. It's not so easy. You can see here, when you write a prompt, how many, and these are the key blocks of metrics that you need in order to evaluate this prompt. And that's why this leads to this fuzzy value creation, which you have to take into account. And at the end, how to introduce AI in the business. Here, in the normal way, and here is the way I did it personally in these three large corporations, with a lot of help at Dow Chemical. It was a collective effort, with shared with my previous boss. We did two people. We did it at Steelcase, and I was It was I have the full freedom to do it from scratch at Georgia Pacific. But usually how you do it is through introducing the technology, finding a proof of concept, and then if it works, then you usually begin to uh, do it in a more generic way and to leverage it in the company. It's easy to say, there are a lot of little details, but what matters and what triggers the process is to have a support of the business and the vision of the top business. If the top business is not convinced, don't waste your time. And here is the steps, because this is probably your way of introducing business. That's why I'm a little bit more detailed into introducing Gen AI. But I again begin with this. You have to be sure that the top business decision makers are convinced that Gen AI is a technology that will help their business. This is in their vision. You have to have this answer. If you don't waste your time. And then is the technical, then it is very logical. Then try to find use cases in the literature, which is close to what you try to solve, to your use case, and prepare to find the domain knowledge, to prepare to find the documents, the books, on the topic you need to solve. And it's inevitable. You have to have some training in prompt engineering and, in fact, training in software infrastructure, because now it becomes more and more difficult with these new methods, RAG, etc., in order to filter out the domain knowledge. So you need probably a good experience in Python too, and evaluate how you can create value with this. Finally, the biggest problem, the skill set problem. It has a short-term solution, and probably some of them has gone through this route already. Because here is, if you stay within Gen AI, all you need is prompt engineering. That's the philosophy. Even the ultimate case is, in a couple of months, I can become a ChatGPT millionaire. Unfortunately, it's not enough to me. To me, I see the road on AI as a long road. And in order to survive in this long road, you need to pass through AI-based data science. Data science as a discipline combined computer science and math and statistics, and on top of that, the basic AI technologies. How we can do it? Usually in the United States, we have this structure. You have the leaders, the unicorns, the data scientists that do the projects, and the wide range of users of the technology called citizen data scientists. And the numbers you see here are the real numbers in the company I consult. And we have 3 groups with about 50 data scientists, and we have trained about 600 citizen data scientists. And we have to go through citizen data scientists. And here what I offer is, I have a partner in Bulgaria called Smart Varna, where we have 3 courses. But what I would suggest, to begin with the business leaders, first to convince the vision, to test the vision, and to learn about the vision, and then to go to data science and to the mass scale. And for the vision, I have this course of Innovate AI. For mass scale is Learn AI, or for those who would like to apply it is apply AI. The last slide is for the book, but from what I heard, you know about the book, so I'll stop here. Thank you very much, and I open and I expect your questions.